Good morning students. Today we will see the Orifice Meter experimental setup. The aim of the experiment is to determine the flow of water in the given pipe. So this is the experimental setup, and in the experimental setup the Orifice meter is fitted in the given pipe, and this is the inlet pipe, and this is the outlet pipe, and this is the collecting tank, and this is the sump tank. First reading we want to take adjust the discharge valve. Then similarly we want to take the manometer reading, that is H1 and H2, that is the left limb and right limb. At the same time we want to measure the flow of water for 10 centimeter rise, and for 10 centimeter rise we want to know the reading for the for every 10 centimeter rise, we want to use the stopwatch, and we want to take the time taken for every 10 centimeter rise. And we want to measure the area of the collecting tank, and we want to measure the actual discharge. And using the Orifice Meter formula, we want to calculate the theoretical discharge. The ratio between the actual discharge and the theoretical discharge will give the coefficient of the discharge. So this is the complete setup for the taking the one reading. Similarly, we want to take the 5 readings. The average of the 5 readings will give the coefficient of discharge for the given Orifice meter.
Students, next part is the tabulation part. As we seen in the Venturi meter, the same procedure can be carried out in the Orifice meter also. First reading is the H1, that is a reading taken in the left limb, and H2 is the reading taken in the right limb, and difference in the manometer is H1 minus H2, and total aid is calculated using the formula, that is the specific gravity of the mercury divided by the specific gravity of water minus 1 into the difference in the manometer reading. Using this formula the total head can be calculated. And next, time taken for the 10 centimeter rise in the collecting tank be noted, and the actual discharge can be calculated using the A into H by T, that is the A is the area of the collecting tank, and the H is the 10 centimeter rise, and T is the time taken. And third part is the theoretical discharge. Theoretical discharge can be calculated using the formula A1 A0 divided by root of A1 square minus A0 square into root of 2GH. Here A1 is the area of the inlet pipe, and A0 is the area of the orifice meter, and using the pi by 4 d square you can calculate the area of the inlet pipe and the area of the orifice meter also. So next part is the coefficient of the discharge. Coefficient of discharge can be calculated using the Q actual by Q theoretical, as in the case of Venturi meter. So the average of the all the reading will give the coefficient of discharge for the given pipe. Thank you.